All right, so our packet today, or what we're going to talk about, is molar mass.
What is molar mass, Ms. Russman?
So it's the mass of 1 mole of a substance.
Okay, so a mole, there was a fancy number. 6.02?
Times 10 to the 23rd.
Okay, that was like an unimaginable amount.
Yes.
Okay.
And in the brain pop you actually watched just earlier in the packet before this, they told you that 1 mole of a substance is the mass off the periodic table in grams.
Oh, so like if I look at the periodic table here, the molar mass of lithium right there is 6.941?
In grams, correct.
Okay, so that's how much 1 mole of lithium weighs.
Mm-hmm.
Interesting. Okay, got it. So should we practice finding those?
Yep, sounds good. So in case you didn't get that hint, you will need a periodic table and a calculator.
Okay, first one says potassium, and I did a lot of work on my naming. That's a K, right?
Mm-hmm.
Okay, so I'm going to look on my periodic table. K is right there, so it's 39.098. Do I have to write all those numbers?
General rule, we're going to say 2 decimal places.
Okay, so I just round?
Round to 2 decimal places, which would be the hundredths place.
Okay.
So when I do that, I'm going to look at this, and I'm going to look at the number after 9. What do you think that 8 does to the 9?
That's going to go up.
It's going to round it up. So when I write this, it's going to be 39.10, because it rounds it up to a 10.
Mm-hmm.
And just like everything that we have, it's got units.
I'm interested in your units. Okay, tell me what this is going to be.
All right, so we've got grams, because we said it's grams per 1 mole, so it's grams per mole.
But do we have to write the 1?
Nope, because it's just understood when you write mole that it's 1.
Okay, so let's do oxygen.
All right, so we look at our periodic table.
O, I remember. 15.999. Can I just round that to 16 then?
You can.
Okay. And I remember something about Brinkelhoff.
Brinkelhoff. Sounds like a diatomic element.
Oxygen was a diatomic element, so it should be O2, right?
It should be O2.
So what do I do with that 16?
Well, since we're going to do 2 oxygens, I would propose multiplying it times 2.
Okay, so 16 times 2. So my oxygen's going to do 32.
And again,
grams per mole.
Grams per mole.
All right. That's not too bad. Oh, but this one looks pretty difficult. Potassium sulfate. There's lots of atoms. How do we do that? That's not on the periodic table altogether like that.
All right. So if we had a household scale and we wanted to know what both of us weigh together, and as much as I'd love to say we're skinny enough to both fit on the same household scale, how would we figure out our total mass when only one of us can get on the scale at a time?
Well, we would add them.
Yeah, so take the mass of you, take the mass of me, and we put them together. That's the exact same thing we're going to do. Look up the mass of each one, and then just add them up. But we also have to count atoms in this, too. Remember that your subscripts tell you the number of atoms that you have of each one.
Okay, so that K, there's 2 of those, and I know from up here and from my periodic table that K is 39.10.
All right, so we do 39.10 times 2.
Okay. On my calculator, that's going to give me 78.20.
All right, so it's got 78.20. Now, we're not done.
That was just K2,
That
right?
was just K2. So this was my K2 is equal to, now, how many S's do I have?
Just 1, because there's no subscript.
Just 1, so I go to my periodic table and I find sulfur.
32.066, so that would be 32.07?
Correct. So we'll put 32.07 down here.
Oh, and we don't have to multiply because we only have 1.
Correct.
Okay.
And then how many oxygens do I have?
4.
4. And we said the oxygen was 16 already, so over here to do O4, we're going to do 16 times 4.
That is 64.
We got 64. Now we have all these masses, and just coincidentally we kind of lined them up here. I'm going to put 64 down here on the bottom, and we're going to add them all up.
Okay, I rounded.
Okay, so we've got 1,700, whoop, not 1,000, sorry,
100.
143.3 grams per mole.
Okay, so that's how you get that answer. All right, let's do one more. We have carbon disulfide. They didn't give us the formula for this. Does that mean I have to remember stuff from first semester?
Yes.
Okay, carbon is C. I know that.
Okay.
And disulfide di was 2.
Yes.
And sulfide would be sulfur, so S2.
Mhm.
All right. So we break it apart, right?
Yes.
So carbon, there's only one carbon.
Mhm.
And if I look it up on the periodic table, it's going to be 12.01.
So right. 12.01.
Okay, and then my sulfur, I looked up before for the last problem. That was, sorry. That was 32.07.
But we have 2 of them.
So I'm going to multiply that by 2.
So we do 32.07 times 2, and that's going to equal
64.2.
0.2.
And then we're going to add those up, right?
Yep. Simple as that.
Okay, and I'm going to get 76.2.
Well,
2.1.
2.1. And units again?
Grams per mole.
Grams per mole.
Okay, so I get the Molar mass thing. I can look it up in the periodic table. I can add it up. So what do I do with this?
Well, it just depends. Sometimes they're just going to straight up ask you a question that says, what is the molar mass? And
then all I have to do is that?
You just have to pull it from the periodic table.
Okay.
But it's never that easy.
Okay, you're tricky. What's next?
Okay, so Mr. Domboski and Miss Wilson had taught y'all about dimensional analysis.
Okay.
And
yeah.
that's what we're going to set up next, is because we don't want to know moles of something, because although moles is going to be our go-between. That's how we convert from one substance to another, which we'll eventually get there. But we want to go from like moles to grams, because we can measure grams in the lab. It's harder to say, oh, give me so many moles of this without having to do the calculation.
Yeah, I wouldn't know what to do.
So.
Okay. All right, so let's do a practice one. Why don't you show me how this works? What if we have 3.1 moles of boron?
All right, so we've got a little extra space, so if you want to move your page down here and do this in your notes. So we've got 3.1 moles of boron, which is B.
Okay, and I'm going to set up my tracks, right? That's what they taught me.
So we'll go ahead and we'll put 1 down, because that's all we think we need right now.
Okay, and I know moles have to go on the bottom because I need the units to cancel.
Remember that anything that you have up top, we're just going to cover up the number and literally copy those units right down below, and we're going to give ourselves space to fill in.
Okay, but now we're going to see how many grams this is, but I don't know what to do now.
Well, remember when we talked about the units just literally a few minutes ago, and the units for molar mass were grams per 1 mole?
Like this up here? Okay.
So we're going to set that up the same way. We're going to put moles on bottom and the grams on top, and since we said it's grams of boron, we're going to put a B,
Okay.
and keep it labeled. Now, since we said it's 1 mole, we only want 1 mole, and the mass of 1 mole of boron we can find on the periodic table.
Okay, boron is right here, 10.81.
Okay, so that's what we'll put on the top, is 10.81.
Okay, and so then they said to multiply across the top and multiply across the bottom, but the bottom's just a 1, so do I care about that?
You don't.
Okay, so I'm just going to multiply across the top if the bottom's all 1s.
Correct.
Okay, so when I do that in my calculator, I get 33.51 grams.
Okay.
Boron, right?
Boron.
I know you're very specific on your units, Ms. Rustin.
All right, and if we want to check this out, I know we got moles canceled out, top and bottom, and the only thing that I'm left with is grams of boron. And if we're doing this correctly, guys, your units should be the last one on the top, because everything else should cancel out. But again, that's key if you're doing it correctly.
Okay, so let's try another one.
All right.
So that's 3.5 moles potassium sulfate in grams.
Okay, so we start with what they gave us, which is 3.5 moles of potassium sulfate. Man, that sounds familiar.
We just did that up here.
We did. Okay, so guess what? Instead of writing that whole name out, let's write the formula, because that is our shorthand, K2SO4.
Okay, so what's on top has to go underneath, so it's going to be moles of K2SO4. And I want it asked for it in grams, so it's going to be grams on the top. And when I see grams and moles together, I know I should do the molar mass. Do I have to add all that up again since we just did it up here?
Since we already did it, we left out, so we can just copy it from the top.
Sweet. Okay, so that was 174.3. And you always said it's always 1 mole, right?
Yep, so when you see this, we just need to get in the habit of that when you have grams per mole, it's always 1 for the mole. But it's only when grams and moles are on top of each other like that.
Okay, so I'm supposed to multiply across the top and multiply across the bottom, but my bottom's all 1s, so we don't care, right?
Correct.
Okay, so I'll multiply across the top, and I'm going to get 609.79 grams of K2SO4, because I'm going to take that last unit right there, right? Okay, so is that done?
Looks good.
That's not too bad. Okay, let's do one more just to make sure I really have it.
All right.
Convert 75 grams of carbon disulfide to moles. We started with grams this time?
We are starting with grams this time.
Okay.
All right, so we've got grams of carbon disulfide. Sounds familiar because, hey, we just
Oh,
did
look,
it right
it's
up
up
there.
Okay, so CS2. Okay, so now this time, I need to follow that pattern where it goes below. So grams is on the bottom to get it to cancel.
Now, this is key, and this is why it's important that we're putting our substance down there so that we're keeping it consistent.
Okay, and then does that mean I put the mole on top?
Just
okay.
flipped.
Just flip it upside down. So is that 1 always supposed to go on the bottom, or does it always go with the mole?
The mole always gets 1.
So it's going to be 1 on top this time. And since we already figured out the molar mass, we can use this up here, right?
You bet.
76.21. Okay, so now I'm supposed to multiply across the top. So I get 75. And I multiply across the bottom, and I get 76.21. So now I divide.
Yep.
Is it okay to put a smaller number in the calculator first? Because I think that's what that means.
You bet. You read this like you'd read a book, top to bottom. So you want to put the number on top in first.
And then divide it by the number on bottom.
Correct.
Okay. When I do that, I get 0.98 moles.
Ooh, there's a 5 after that.
I think that means I round up. 0.99?
No, 0.99.
Moles of CS2. All right, I think I'm going to go practice this now, Ms. Russman. Thanks for teaching me.
Ask if you need help.
Okay.